right, welcome America, welcome Justin Bieber. I would like to teach to you today polynomial and rational inequalities. We just did, before we started recording, a couple polynomial inequalities. We're going to do one more on this worksheet that is attached, which is problem number 9. Then we're going to move on to rational inequalities that has one extra step. I know you guys love one extra step. It's like your favorite thing ever. I wish Syra was here today. She would love it. If Syra was asking me, does this get harder? I guess the answer right now would be yes.
Great.
Good times. And also, we have an update. Gracie said she would do a cameo with her mom jeans in my next video. So there's that to look forward to. So without further ado, let us move on to number 9. Yes. Okay, so what's nice about number 9 is this inequality is already factored. We don't have to move anything over. We don't have to factor anything. It's already done. So we can go ahead and find the zeros. Those are going to be at x equals 1, 2, and 3. So on our number line, we have to make sure we put those in order from low to high. 1, 2, 3. Now since we've got 3 important points here, this graph crosses the x-axis 3 times, which is fine, but now we've got 4 intervals. We've got an interval here, 1, 2, 3, 4. We're gonna have to check every one of them to see if the graph is above the x-axis or below the x-axis to determine where the intervals that we need, which intervals are less than or equal to 0. Where are the y values less than or equal to 0? So let's go ahead and pick a value below 1. So I like 0. If I plug in 0 here, what are the signs of each of those terms? If I plug in 0 here, I get 0 minus 1, that's a negative. 0 minus 2, that's a negative. 0 minus 3, that's a negative. So this would be a negative times a negative times a negative. And I'm going to write that down here in a different color. I'm just going to write 3 negatives, no parentheses. Negative, negative, negative. A negative times a negative times a negative is a negative. So this graph from negative infinity up to 1 is below the x-axis because these y values are going to be negative. Now let's go to this interval between 1 and 2. Well, that's kind of a pain, but we just pick something like 1.5. We don't have to know the exact values, but if I plug in 1.5 here, 1.5 minus 1, positive. 1.5 minus 2, negative. 1.5 minus 3, negative. So this would be a positive times a negative times a negative, which is going to be a positive, which tells us that the graph between 1 and 2 is above the x-axis because the y values are positive. Let's keep going. If I pick 2.5, 2.5 minus 1, positive. 2.5 minus 2, positive. 2.5 minus 3, negative. A positive times a negative is a negative. So the graph between 2 and 3 is going to be below the x-axis because the y values are negative. Last interval. If I pick any number above 3, I'm going to get a positive. Positive, 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 positive. So now we look at what we have. We're trying to find the intervals where the graph of the function is less than or equal to 0, where the y values are below the x-axis, and also including 0, because it says less than or equal to 0. So we need from negative infinity up to 1, and including 1, because the graph at 1 is 0. And this, we need to know where the values are less than or equal to 0. So from negative infinity up to and including 1, hard bracket, in union with from 2 to 3. And we're going to include 2 and 3 because the graph at 2 and also at 3 is 0. and we're asked to find where the graph is less than or equal to 0. So we're going to include the 2 and 3 by putting hard brackets. Are we good? Okay, I feel like this is getting a little easier. Let's step it up. Just kidding. There's one extra. Are you guys finished writing this down?
Wait, sorry.
Yeah.
I always forget, like, hard brackets means like it includes the number.
Yep.
Okay.
It's like when you were graphing in Algebra 1, it's a solid dot on an inequality. The soft parentheses, we always put the soft parentheses around the infinities because those aren't actual numbers, but if you have soft parentheses around a number like 1, for example, that's not including that value. So when you're graphing inequalities in Algebra 1, that would be like an open dot. Yep.
Why isn't like the last like interval to like positive? Like why does it stop at 3?
Because from 3 to infinity, the graph, the y values are positive. And this particular problem is asking for where is the graph less than 0. Had the question asked where are the values, where's the graph greater than 0, we would have said this interval from 1 to 2 and this interval from 3 to infinity. Okay. Where am I at? I'm at 6 minutes. Okay. So definitely gonna do number 11. We'll see how long it takes. So number 11, these problems have basically one extra step, okay? Because we've got a denominator here. This is a rational inequality. So we've got an asymptote. We've got a vertical asymptote at 0, and we just finished that in our last unit. So when we have a vertical asymptote, I can't draw on my board. Spring 2022 for my smart board. Okay, so I'm just gonna make up some asymptotes, okay? So let's just say right here, okay? Those are my asymptotes. And let's say I had a graph that looked like this. Just doing a concept here, okay? So if you have an asymptote, it's another important point that we're gonna have to put on our number line, including also the zeros, because we could have changes there. For example, this graph, super messy, but you can see there's a change at this asymptote, because here this graph is below the x-axis, and then right at the asymptote it changes, and now it's above the x-axis. So we not only are going to have to, on our number line, put the zeros, we're going to also have to include the asymptotes and check on either side of the asymptotes. And we can never include the asymptote. That's different than the points that we were just including. Let me go back to that one. Number 9, we just finished. Where's number 9? This problem was asking where's the graph less than or equal to 0. So sometimes we will include those actual zeros, but we're never going to include an asymptote because there's no graph at the asymptote. So let's go back to number 11. Let me erase this mess. At least it's got different colors. Okay. So, number line. There's not much work we've got to do ahead of time. We can tell that the zeros are at 1 and -1. But we've also got an asymptote. So I'm going to have to put 3 points, important changing points on my number line. I'm going to have to put 1 and -1 and also 0. One makes that factor 0. -1 makes that factor 0. And then we also have an asymptote at x equals 0. And we have to put them in this order because this is a number line. We have to go from low to high. Are you with me so far? So now what we're going to do is we're going to check the values just like we did in the last problems. Okay, if I put a -1 in, or no, something below -1 over here. We're going to check this interval, this one, and this one all separately. So I have to put in something like -2. So that's going to be a negative times a negative over, if I put a negative in the denominator, -2, that's going to be a negative. So it'd be a negative times a negative over a negative if I plug in -2. Now, that's going to be a positive over a negative, which is going to end up having a sign value of a negative. Is everybody okay with that? Between -1 and 0, if I pick a point like -1/2, for example. -1/2, I plug in here and here and here. What are the signs? No, -1/2, right? Somebody check my work. There we go. Okay, that should be positive because this is going to be a negative over a negative, which is a positive. Now, maybe 1/2, positive 1/2. Negative times a positive over a positive will give us a negative. And the last one, those should all be positives. Now this is important, okay? Where is the graph less than or equal to 0? So it's less than or equal to 0 from -infinity up to and including -1. Because -1 is, the graph is 0 at -1. In union with. The second interval is right here, between 0 and 1. However, at 0, there's an asymptote, so we are not going to include 0. But we are going to include the 1 because the graph is 0 at 1. So when we write this interval, we're going to say from 0 to 1 and include the 1, but not the 0. That was a perfect example for soft brackets, hard brackets. Any questions on that? You might have a question about this. The asymptotes are kind of tricky.
Could you explain like how you got that union? I didn't understand.
So since this particular question is asking where is the graph less than or equal to 0, where are the y values below the x-axis? And we just figured out they're below the x-axis here from -infinity to -1, and also from 0 to 1. So we have to include both of those intervals. And that's what the union means, this interval and also this interval. So the graph is below the x-axis from -infinity to -1. It's equal to 0 at -1. And also between 0 and 1. From here to here and here to here. Good? Yep.
Why is 0 not included?
Because there's an asymptote there. And the question is asking where is the graph less than or equal to 0?
Okay.
There's no graph there because it's an asymptote.
How do you know that there's an asymptote?
Because from the last unit, when we have, we take a look to figure out where the vertical asymptotes are, it's when the denominator, whenever you have a denominator equal to 0.
Okay.
Remember how when we were looking for the horizontal and the vertical asymptotes,
Yeah.
we took the denominator and we said, all right, where is the denominator going to be 0? In this case, the denominator will be 0 at x equals 0. If I plug a 0 in here, I'm going to have a 0 in the denominator, and then I'm going to have no value to plot on my graph because there's no graph there.
Okay.
It's undefined.
Okay.
Okay, good questions. Anything else? All right, don't forget to show me your mom jeans. All right, peace out.